Hello, friend, and my fellow enthusiastic. Welcome to this extraordinary video session on a Spark, where we embark on captivating exploration of Spark. Like already we discussed lot. So get ready to be inspired, entitled, and engage in this world of Spark. Okay, so let's dive into. And today, you know very well. Today onwards, I'll start a new video series on a Spark, and this series basically we will focus on Spark optimization side. And this video will be like beneficial for those who belongs to a IT sector, basically having good experience in Spark and big data tools. So basically I have designed, I'm gonna start this video series for those especially. And guys, one more important news I just want to tell you that soon I'm going to start my new batches on Spark and optimization. So do let me know, and please do a comment in our video section, and please paste your mail ID if you are interested to learn this Spark and their video series. So please share me your mail ID and contact number, so I'll contact you, and I'll share you the detail when we are going to start the new session on the this Spark series. Okay, welcome to our video series on a Spark memory management in our education. So in this optimization of Spark, basically we will discuss about like memory management in Spark, like what type of errors we are getting. We know, because writing a code is very easy, but when data growing and same code is running on that huge amount of data, so we will face a lot of issues. So that is the real problem. So how we can solve those problems? So this is the real target which we are going to learn in this Spark video series. So in today's video session, I'm basically discuss about the Spark memory management system, which is very interesting and fabulous topic. Okay, so let's get a start. So welcome this Spark memory management system, guys. And so here we are. Whenever before going to start this session, these question always running in your mind whenever you are like process your data on process your Spark application on huge amount of data. So these are the question, like how do you handle OOM issues in Spark? So generally OOM stand for out of memory issue, and there are two types of generally out of memory issue we will get from driver side and executor side. In Spark there are two things. If you want to understand what is driver, what is executor, what is the architecture of Spark, so in description section I'll paste all the link about the Spark series. This is a different series of Spark where we especially like focus about the Spark optimizations. Okay, we will cover a lot of things like what is Spark memory management system, what type of driver out of memory issues, what is executor out of memory, see what is the internal joins inside the Spark. So these are the things we are going to cover in this Spark optimization series. Okay, so why your Spark application are slow or are failing when you design a code, very simple code, like reading some CSV file, processing, and it's running fine. When the data getting like huge, and you guys are shocked. Oh, what the hell is going on? My job is slow down. And I'm getting a very like weird errors and all that. These weird errors basically like out of memory issues like executor, because you are not properly defined, like proper you are not properly choose the executors like resources and all that. So and then Spark can spill the data to the disk, means you know that Spark basically designed for memory, like it provide you a fast processing, but inside a Spark you can spill over your data on the disk. So why still we are getting the error? This answer you will get at the end of the video. Why Spark can spill the data to the disk, so why would it fail without of memory exception? I'll cover these things. Okay, so before that you can if you know the answer, so do in comment section. So if I like your comment, and so definitely I'll chase you. And don't forget guys, soon I'm gonna start my new video series, so please paste your mail ID and number, I'll contact with you and I'll share you when I'll start my next session on the video. Okay, so here is the agenda, what we will discuss, like the concept behind the memory management of Spark executor, heap memory, difference in execution memory and storage memory. These are generally a part of the heap memory. Inside a Spark we have a three type of memory: heap memory, off-heap memory, and overhead memory. One by one we are going to cover, but basically we will focus on that heap memory part, where most of the Spark developer are aware about this heap memory, and we are getting the out of memory heap out of memory issues basically. So difference in execution memory and storage memory, which is also a part of the heap memory. And then dynamic occupation mechanism. There is a very like fascinating feature provided by the Spark. Like you can extend the boundary of execution memory, even you can extend the boundary of execution memory, like dynamic kind of things. So we will see in upcoming videos. So then off-heap memory and memory overhead, due to which we are getting a lot of out of memory issues and from driver side or executor side. So one by one we are going to discuss. So let's jump into it. So here you can see out of memory issues. So Spark application include two JVM process, and often like OOM, out of memory, occurs either at the driver level or a executor level. So common out of memories are Java heap space out of memory, exceeding executor memory, exceeding physical memory, exceeding virtual memory. So these are the famous memories, like out of memory issues mostly Spark developer face during their when they submit their jobs and all that. Apart from there, lot of like broadcast, many more facing. But if you want to avoid these stupid out of memory issues, so guys, let's focus on Spark memory management system. And here we will especially focus on executor side, not on driver side. Okay, keep it in your mind. For driver side, I'll cover it later, but my prime focus on executor memory. And most of the question during the interview time, they normally ask you on that executor memory. Okay, so Spark memory management system, guys. Spark version 1.6. Again, I'm repeating 1.6.0. Before that, there are some different memory management system like static, you can say that, and I'm not gonna cover that part. If you want to understand, if you want to learn like how Spark behave before Spark 1.6, what kind of the memory management system inside it, so I have already pasted the link here, like http opp. You can visit on this site and you can easily learn the old Spark memory management system, which is generally called a static memory manager. Okay, so after Spark 1.6, scenarios change, which is we are going to discuss here. You can see that Spark memory management generally executor memory management and driver memory management, but here we have a focus on executor memory management, off-heap memory, and on-heap memory. Apart from that, the third one is overhead memory. So and in these three, basically the important one where Spark developer knows the memory, knows like most of the memory, like on heap memories. Okay, so here we go. Guys, you have heard this yarn cluster manager in my Hadoop video series. So again, I'll paste the link of the Hadoop video series link, so where I'll discuss this topic yarn, and you can just visit over there and you can easily learn this yarn topic, what exactly this yarn, how beautiful in Hadoop 1, what kind of the disadvantage of the Hadoop 1. So then in Hadoop 2 they introduced this yarn concept, and through their big data a huge revolution came in big data field, like a Spark introduced in the picture, because before that Spark worked separately, big data and Hadoop is worked separately. But after yarn came into the picture, the other processing framework, like through yarn, they are ready to process the data which is stored inside the Hadoop. So big picture, if you want to seriously learn, so go in a description section, you can see the Hadoop introduction section, architecture part, where I'll have covered these topics like yarn and all that. So here I'm give you a quick overview what yarn is. A yet another resource negotiator. When submitting a Spark job in a cluster with a yarn, so yarn allocates executor container to perform the job on a different node. So resource manager handle memory request and allocate executor container up to the maximum allocation size settled by the yarn scheduler maximum allocation MB configuration. So memory request higher than the specified value will not take effect. So it means that whenever you are submitting any Spark application, so it will contact to this cluster manager. There are three different types of cluster manager inside a Spark: Yarn, Mesos, and standalone. So mostly people in a in a IT sector, in a company, they use this Yarn. So they contact with this Yarn. Inside a Yarn, there are some daemons, some properties like resource manager, node manager, application master. So they contact with the resource manager. Hey, resource manager, provide us some container where I can run my task and job on Hadoop data. So resource manager allocate the memory to these Spark jobs and all that, and it will launch their jobs inside these containers. So on a single node, it is run by the node manager. Node manager has an upper limit of the resource available to it because it is limited by the resource of one node of the cluster. And in Yarn, it set up by the Yarn node manager resource memory MB and configuration. It is the amount of physical memory for per node manager in MB, which can be allocated on the Yarn container. In broader view, you can say that Yarn is a cluster manager. It will help you to launch a container for your Spark job on Hadoop cluster, on a Spark cluster, because already Spark is on top of Hadoop. Okay, so here you can see the broader picture. This is your like Spark driver. Whenever you submit Spark application, I'm hoping you are aware about these Spark driver, Spark context. If you are not, so again in description section there is a video of Spark architecture. Like whenever we are submitting any Spark job, so it will launch your Spark driver. Inside a Spark driver, they launch your Spark session, and then their DAG, inside a DAG, stages, multiple tasks, and then these tasks like driver contact to cluster manager. Can you launch my these tasks on whenever you perform any action? So then it will start launching your job on different worker node, where inside a worker node we have a different executor, and it will launch your task on it. Okay, so this is a broader picture. So where resource manager is also play a very vital role to create the container on those worker nodes. Okay, so executor container, if you can see that the picture of executor container. So whenever any job run on any node manager, because I told you that now node manager and worker node, these are all slave. So in Hadoop terms, whenever dealing, because a node manager inside a node manager, you launch your executor container, and you can launch executor like more than one, two, three. It's up to you. So there are some approach which we are going which already I have covered. I think not covered. I'll make a video on that. There are some tiny approach, fat approach, and middle approach, where we will decide like what will be the like how many executor you can create in each worker node, and how many memory you can allocate the executor, like maximum executor you how you what is the maximum executor, how much maximum executor you can create inside one node manager. So it right now you can you can imagine like in node manager you can create more than one executor container. Okay, so maybe one, two, three, it's up to you. Okay, so this is a node manager inside a executor container, and these are the three beautiful things like off-heap, heap, and overhead. So first of all, we are going to discuss this heap one, and then later on off-heap and overhead. But our prime focus always on this heap side, where executor, where a Spark developer is known about these things. So Spark executor memory, and this is Spark memory of, these are the some property. Whenever you are submitting your Spark job now, so through Spark property you will pass these things. Okay, if you remember this Spark executor memory, you pass like 16 GB, 5 GB. If I know you know very well these things. So here you can see that this is your yarn. Inside a yarn, this is a executor container, and here you can see that this is your heap memory, heap space. Inside a heap, we have a different memory segment, which we will cover later, like user memory, Spark memory storage, Spark memory fraction, reserve memory. So one by one we will talk these things. We will gonna discuss these things. And apart from that, there is a Spark yarn executor memory overhead. We will also talk about it, like whenever you launch your, because you know very well these executor container all are virtuals. So whenever like how much memory required for whenever you are launching these executor containers. So if it is extend that limit, so it will throw you some error memory overhead, which we will gonna cover. Okay, so again in a border view, I have pasted many slide guys for you, so it will become easy for you. Here easily heap memory. I told you that inside a executor memory we will discuss heap memory, off heap memory, and overhead memory. So here in heap memory we will gonna discuss these four term basically, like reserve memory, user memory, and then execution memory and the storage memory. As I told you that dynamic occupation mechanism. It means that execution memory can take storage memory part as well, and storage as well take the execution memory part. So these are the executor memory and these are the usable memory. Generally a Spark developer dealing with these can precisely choose user memory and execution memory and storage memory, and can optimize their job. Okay, and then off-heap memory. It is a optional one, but I'll cover this part also. So like off-heap size memory, by default it is disabled, as I told you that. If you want to enable it, so I'll tell you how you can enable this property and what kind of benefit you will get and what kind of disadvantage of it. We will cover. There is a one topic like GCC, like garbage collection, where in heap memory we can automatically perform, but in off heap memory it is not perform automatically. You have to do manually, and which is very pathetic. I'm trying to avoid these things. Okay, overhead memory, like Spark executor overhead memory, like 10% of executor memory container of the minimum of 3. I'll also cover the container size, like how much memory. I'll calculate this practical part also. Okay, so till here, thanks. Now jump. Again, one more PPT, pathetic. So I'm not gonna discuss in a detail. Again, same thing, overhead memory, off-heap memory, and this is heap memory. Okay, jump on next slide. So now finally I reach where I'm gonna discuss heap memory, off-heap memory, and overhead memory. These all are part of your executor memory. So one by one we are going to discuss heap memory. So I hope whenever anyone discuss about this heap memory, so automatically click on your mind, oh, heap memory. So inside a heap memory he is going to discuss like reserve memory, user memory, execution memory, and storage memory, and these are the usable memory. So this is the memory that should be known to most Spark developer, as I told earlier, and this is the memory size specified by executor memory. If you remember, you always pass -FN executor memory like 5 GB, driver memory like 4 GB, something like that. So I hope you are about this property. So you with the help of this property you can optimize your jobs and all that. But how you gonna decide like which part contain what, and how we can decide like memory for this one. So during submitting Spark application or by setting Spark executive memory, it is maximum JVM heap memory, and objects are bound by the garbage collectors. You know? So later on I'll cover this garbage collector. Actually, garbage collector is nothing. It will help you whenever you are storing any old objects, any old data. So whenever we are going to face any out of memory issue, so first garbage collector internally what it will do, it will try to remove all the old data or old objects which are no longer in use. Garbage collector automatically delete those object and data. So it will try to help you not getting any out of memories issues. And so garbage collector internally like try to help these things. So I will call this part of memory executor memory. So the amount of memory available to each executor controlled by, you know very well, executor memory, Spark executor memory. So here breakdown you can see that. So let's consider it 4 GB RAM. So how we can do the breakdown? So first, this is your executor. Let's consider this is the reserve memory. So what exactly reserve memory store? We will cover on next slide. Reserve memory generally contain Spark internal objects. and it is fixed like 300 by default. 300 MB we will assign this reserve memory. So don't worried about this reserve memory. You cannot do anything. You can't do anything for this reserve memory. Always like say whenever you are Spark internal object generally store inside this memory. Okay, the another one this one what we call like consider it, you have a 4 GB, you are assigning a 4 GB RAM for this executor, like executor memory 4 GB. So 300 is gone. So how many is left? 3796 MB is left, where we can play, where Spark developer can efficiently decide and design. Okay, so what is another part? And this part is generally also called like Spark memory fraction. Okay, so inside the executor memory there is a reserve memory and rest part Spark memory fraction. The another one is part like user memory, and user memory is 1 minus Spark memory fraction. So it means that like 25% of it. So you can just count 25% of it. So you will get user. So what exactly this user memory? What exactly it is stored? Guys, do you remember whenever you are writing any Spark application like creating variables, class objects, UDFs. So these type of information it is stored inside it. So if in your Spark application, if you are using lot of object, lot of UDF, try to avoid these things. And the objects are a variable. So generally these type of information normally store inside this user memory. Okay, and the rest part like execution memory and storage memory. Okay, so three types of memory basically: reserve memory, user memory, and Spark memory. So in Spark memory, like storage memory and execution memory both will come. We will discuss one by one. So user memory, you can just minus Spark memory fraction, so 25% of your memory, and 300 is fixed for reserve memory and Spark memory. Okay, so let's understand each section in a detail. So here you can see reserve memory 300 MB by default memory allocated, Java heap memory, and user memory like 1 minus Spark memory fraction, and it's 25% of. Then this Spark memory divided into 50% used by storage memory and 50% used by the executor, like execution memory. So Spark memory fraction default is 0.75. Okay, default is 0.75. Okay, and so Spark memory storage fraction is default to 0.5. Means this is a 0.5, so this is also a 0.5%. Okay, so for the sake of we are discussing 4 GB memory and how we are dividing these energies. So this is the Spark memory fraction. Okay, so let's get jump one by one. We are going to discuss this. The first one, reserve memory. What I told you, this memory reserved by the system, and its size is hard coded. As of Spark 1.6, its value is 300 MB, which means that this 300 MB of a RAM cannot be changed unless Spark is recompiled, and this memory store Spark internal object. So one thing to note is that if the executor memory is less than 1.5 times of reserve memory, so Spark will fail with the please use larger heap size error message. This type of message you will get. So if by default it is set 300 MB and you are like using less than that of it, so it will throw you this error. Please use the large heap size. And calculation of the 4G out of 4 GB, we assign by default 300 MB for this. Another one, user memory, which is very important, and I'll humble request to all developer, please whenever you are writing any code, so carefully used object, data, variables, and all that. So this memory area that store all the user defined data structure. User, we are user, and UDFs created by the user etc. And this memory segment is not managed by Spark. The Spark will not be aware of maintain of this memory segment. Who is responsible then? We are responsible for them. Okay, so the Spark will not be aware maintain of this memory segment, and the size of this memory pool can be calculated as Java heap minus reserve into 1 minus Spark memory fraction, which is by default equal to like Java heap minus 300 MB into 0.25. As I told you that user memory, Java heap minus reserve memory into 1 minus. So 1 minus Spark memory fraction you know very well, 0.75 allocated by default. So it is come around 25. So 25%. So in 4 GB you can minus 300 MB for your reserve memory and apply 25% on that memory. Already calculation is simple. Don't go too much far. As I told you that user memory is 25%. So you can perform 25% on the memory which is left after removing reserve memory. So 25% on that memory. So you will get 949 MB around. So for example, you can rewrite Spark aggregation by using partition transformation to maintain a hash table for this aggregation to run, and which would consume so-called user memory. Okay. And the next one is like Spark memory, generally divide 50-50%. So rest is 75% is left. So you can minus reserve memory from the Java heap memory, and what will be the left? You can perform 75% of, because 25% for user memory, rest is 75, and this memory now divided into two parts. This 2847 MB which is left after giving memory to a user and reserve memory, and this will 50-50% divide in storage memory and the execution memory. And this is responsible for storing the intermediate state while doing the task execution, like joining, RST, storing the broadcast variables. All cache persisted data will be stored in this segment, specifically in the storage memory on this. If you remember, some data frame you always persist are a cache, so generally it is stored inside this storage memory. In my most of Spark video sessions, I have shown you like how you can persist and cache your data. And then this is the execution memory. Whenever you are performing any shuffle, join, anything at, so this execution memory play a very vital role over there. Storage memory, now one by one we are going to discuss how you are gonna calculate. So Java heap memory 4 GB minus reserve memory, whatever you will get multiply by 75% of it, and Spark memory storage fraction is also a 50%. So you will get like 1423, which is just half of 284 something, which discussed in previous slide. So, and same for execution memory. So the basically in storage memory, what kind of data we store? So you know very well, when you cache some data or persist some data, broadcast variable are also stored here. Any persist option which include memory in it, Spark will store the data in this segment, and Spark clears space for new cache request by the removing old cache objects and based on the least recent use mechanism. Okay, and broadcast variable are stored in the segment with memory and disk persistence. So execution memory, this memory region is used by Spark for object created during the execution of the task. And for example, it is used to store the hash table or the hash aggregation step. It is used to store the shuffle intermediate buffer on the map side in memory. And this pool support, again same calculation formula. Okay. So now dynamic memory, dynamic occupation mechanism. Here you can see that in this diagram, like execution memory can take us some part of storage memory, and storage memory can also take a part of execution memory during the runtime of your job. So if you will pass some property, so here you can see in this diagram, execution take some part of storage, but there are some threshold. If that threshold is crossed, so it will automatically remove. So what is exactly this dynamic occupation mechanism? Execution and storage have a shared memory. This is what we call shared memory, and they can borrow it from each other, and this process is called dynamic occupancy mechanism. If someone asks you what is dynamic occupation mechanism, you can say that is storage and execution have a shared memory part. They shared from each other during the time of processing. Okay. So execution use storage memory. So there are two parts of shared memory: storage side and execution side. And the shared storage memory can be used up to certain threshold. And in the code, this threshold called on-heap storage region size. On-heap storage region size means like you can fix this property. And this part of memory is used by storage memory, and but only if it is not occupied by execution memory. And storage memory has to wait for the use memory to be released by the executor process. And the default size of on-heap messages is by default for storage memory. And same for storage execution side. When execution memory is not used, execution memory, so carefully you decide. Suppose in your application, if you have a more processing part, you are not going to like store data on storage memory, and you have more execution part. So try to go with this execution memory approach. And if you have less processing part, mostly storage part, so then you go then try to use this storage phenomenon. So when execution memory is not used, storage can borrow as much execution memory as available until execution reclaim its space. Guys, if you remember, suppose in your application you store data frames already, many data frames, and you also occupy the execution space. But later on, you realize that execution want their space again back. Please give it to my space back. So that time you also get a error. So that time try to avoid like collect shows, these kind of things, and not to store data on the storage, because this is one of the reason where you can get out of memory issues. So when this happens, cache blocks will be evicted from the memory and until sufficient borrowed memory is released to satisfy the execution memory request. And the creator of this mechanism decide that execution memory has the priority over the storage memory. So always keep in your mind, the creator who like create this phenomena, execution always have a huge priority over the storage memory. So they had reason to do the execution of the task is more important than the cache data. The whole job can crash if there are out of memory in the execution. So this is the phenomena of it. Okay, and both overhead like if a space on both sides is insufficient and within the appropriate boundaries, so it is evicted according to their respective storage level using the LOR algorithm. And the eviction process has its overhead, and the cost of memory eviction depend on the storage of level. And memory only may be the most expensive because it has to be recalculated, and memory and disk relies is the opposite on this storage level. And the format of data stored at runtime is compact, and overhead for the serialization is low. It only include the disk input output. Now the second part already we covered in heap. So if I'll quickly summarize what we have discussed inside a heap memory. Inside a heap memory we have a 4 storage level: reserve, which generally store your Spark internal object, and user memory. Guys, user memory which store your internal objects like your program objects, data, variables. And if you remember in the start of video session, I told you that Spark have a capability to store data on the disk. So still we are getting the out of memory issue. This is a reason, this bad reason. User memory generally it store in data, variables, objects, and which we cannot split on your on the disk. You cannot split some data on your disk. This user memory cannot move. In overhead memory sorry, in off-heap memory, this part we are going to cover. So here you can see that what exactly off-heap memory. Despite the fact that most operation are happening entirely on heap memory, I told you that most operation will always perform on heap memory and use the mighty help of GC, garbage collector, GC. And Spark also make it possible GC and Spark also make it possible to use off heap storage for certain operation. and this memory does not bound to GC. I told you that whenever you are using on heap memory, so inside a on heap memory there is a inside a on heap memory you have a GCC. So GCC, what role GCC will play? Garbage collector. So whenever you are getting like shortage of memories and all that, so shortage of memory, so what GCC will do, it will try to remove or delete your old objects, old data, which this facility you will get on heap memory inside a executor, but off heap memory outside your executor. And as much like if you have a 3 executor or a 2 executor can use same off heap memory. So what kind of advantage you will get off heap memory? Suppose if GCC inside a GCC already delete your objects, your internal objects and all that, still you have a insufficient of memory, so then it try to spill over your data on off heap memory. So this memory does not bound to GCC but call the Java API for unsafe operations such as C, which use malloc to use operating system memory. And this way Spark can directly operate the off-heap memory, reducing unnecessary memory overhead and frequently GC scan and GC collection, and improving processing performance. So off-heap memory, like additional benefit, but guys, you have to manually clear this data inside it. You cannot like automatically you cannot clean the data inside of your memory. Yes, because we don't have the control on it, because in these executor automatically GCC and other can help to clean your data, but off your memory you have to manually manage these things. And already I said you there is one property by default, it is disabled, but if you want to use this off heap memory concept, so you can use it. Means like additional feature of Spark, whenever you are running job and you are getting some out of memory issues kind of thing, so you parallelly start using this off heap memory. If you have enabled this property and set the memory to it, so it will throw your data or a task on this off heap memory. Okay. And then overhead memory. Overhead memory. Overhead memory. So when allocating executor container in cluster, sorry. Now overhead memory. So when allocating executor container in cluster mode, additional memory is also allocated the things like VMM. So when allocating executor container is in cluster mode. Okay. So additional memory is also allocated for the things like VM overhead, intern string, other native overhead. Why I'm telling you overhead memory? Whenever you are, these are virtual machines, you know that executor, driver memory, these are virtuals kind of thing. So whenever you are creating your executor container and all that, so you always suppose whenever you are creating these executors on your node manager and all that, these are virtual machine, and for creating these virtual machine you need some overhead. You will get some VM overhead, intern string for creating these virtual machine, and this memory is set using Spark executor memory overhead configuration deprecated Spark yarn executor memory load, and the default size of is 10% of your executor memory. Suppose if you are passing 4 GB memory na, so 10% of it, like around 0.4 something, with minimum of 384. By default it is 384. If you are allocating 4 GB and 10% of it which is larger than that, so it start using that memory, not default memory. Okay. So this additional memory include memory of a PySpark executor when the Spark executor PySpark memory is not configured, and memory used by the other non-executive process running in the same container. So Spark 3.0, this memory does not include off-heap memory. The overall memory is calculated using the following formula. So here you can see that, guys, how, okay, formula is not there. Okay, so so formula, guys, already I told you that 10% of your executor memory, and and by default it is 384. Means it will pick if you can see 5 GB MB, 4 GB MB is like 4096, and what is the 10% of it? It is around 400 something, so which is greater than 384 MB, so it will take that part. And if you are passing executor memory like 2 GB, so 10% of 2 GB is something around 200, so it will pick it will take this 384 MB kind of it. So always keep in your mind whenever you are passing whenever you are allocating executor memory, so keep this memory overhead in your mind. So this is nothing, it help you to create your VMs, virtual your executor container, where we need like a VM overhead internesting, so where we have waste our most of the times. Okay, so handle these parameter like here is a list of component which is very important of every job, like is Spark executor core. This is important, which is take care of your heap memory, and Spark driver code, driver memory, which we will cover in our next video session. And here is a list of component to be considered depending upon the job, like memory overhead, extra Java option, extra Java driver, extra Java option, executed memory fractions, memory storage fraction, memory off is off if enable. If you want to make it true or a false, it's up to you. And off if size, which is an auto broadcast join threshold, which is generally -1 we set. And this concept this thing I'll cover in my next video, where, when I'm gonna discuss about join strategy inside the Spark. So I hope guys you like this session, like where we covered Spark memory, where we covered Spark memory management, like off-heap memory, on-heap memory, and memory overhead. Inside a heap memory, we discuss about like executor memory, driver memory, and basically we covered focus on executor memory side. And inside our executor memory, what we have covered, like on heap memory. Inside on heap memory, we divided on heap memory in 4 parts, like reserve memory, user memory, then storage memory, and execution memory. And storage and execution memory, there is a concept like dynamic occupation concept. So these are the things. And memory overhead we discuss, and off-heap memory we discuss. I hope you like the session. So don't forget to subscribe my channel, and please press the bell icon. And if you have any doubt, any question, so please do a comment in the comment section. And as I told you that I'm gonna soon I'll start my videos for a Spark developer. So please comment your mail ID and number, so I'll reach you and we will plan for this. Thanks. Okay, bye bye. Okay, bye bye. Take care.